Let's talk on properties of imaginary units. This I is called imaginary units. Properties of imaginary units. I square will be equal to minus 1. Find I power 5. I power 5 will be equal to I square times I square times I. Here we know that I square is negative 1 times negative 1 times the I. This will be equal to negative 1 times negative 1 is equal to 1 times I will be equal to I. I power 5 is equal to I. You can be asked also to find I power 6 will be equal to I square times I square times I square, which will be equal to negative 1 times negative 1 times the negative 1. Negative 1 times negative 1 is equal to 1 times negative 1 is equal to negative 1. I power 6 will be equal to negative 1. Let's have a simple question. Solve in the equation in C. We know that C is a set of complex number where x square negative 6x plus 18 equals 0. Here A, it is the number before x square. A is 1, B is negative 6, and C is equal to 18. A is equal to 1, B is equal to negative 6, C is equal to 18. Discriminant will be equal to B square minus 4 times A times also C. And then discriminant will be equal to negative 6 square negative 4 times A times C, which is 18. And then discriminant will be equal to 36 minus negative 4 times 1 is equal to negative 4. Negative 4 times the 18 will be equal to 72. Then 36 minus 72 will be equal to minus 36. You know, discriminant is negative number. It means this equation has no real roots. It has complex roots. That's why discriminant will be written as 36 times z minus 1. Then discriminant will be equal to 36 times the I square, because this negative 1 is equal to I square. X1 will be equal to minus b plus square root of discriminant over 2a. X1 will be equal to minus b is minus 6 plus square root of discriminant is the square root of 36i square over 2 times a which is 1. It will be equal, x1 will be equal to 6 plus 6i over 2 is equal to 2 factor of 3 plus 3i over 2. I simplify 2, I will get 3 plus 3i. This is x1, where this 3 is a real part and this 3 is the imaginary part. X2 is equal to minus b, negative square root of discriminant over 2a. X2 will be equal to minus 6 minus square root of 36i square over 2 times 1 is equal to 6 minus 6i over 2. Then x2 will be equal to 3 minus 3i over 2. When I simplify, I get x2 is 3 minus 3i. This is x2. This x2 and x1, they are called complex roots. These complex roots are the roots of a complex equation. Modulus of a complex number. Z equal to A plus IB. The modulus of Z is found by taking real parts square plus imaginary parts square, all in square root. A square plus B square, all in square root. This is how we can calculate the modulus of a complex number. Example, Z is equal to 1 minus I. Find modulus of Z. The modulus of Z, it will be, we know that this one is real part, and here in front of I there is minus 1. This minus 1 is imaginary part. Then modulus of Z will be 1 square plus minus 1 square, all in square roots. The modulus of Z here will be equal to square root of 1 plus another 1. Then the modulus will be equal to square root of 2. Another term, in different books, you can get where modulus is written as R. You can say that R is equal to square root of 2. This is the modulus. Polar form of a complex number. Example, Z equal to 1 plus I. This form, which is written like this, is called algebraic form. So then we are going to find polar form. Before we calculate polar form, we first look for what we call argument. Argument of Z, which is equal to 1 plus I. We are going to find it. Argument cosine theta is equal to real parts over modulus, while sine theta will be equal to imaginary parts over modulus. Cosine theta will be equal to real parts is 1 over modulus. We can calculate first modulus. Modulus of our complex number will be equal to 1 square plus 1 square, which is before I, 1 square, all in root. It will be equal to the square root of 2. Then cosine theta will be equal to 1 over square root of 2. And then sine theta will be equal to the imaginary part of our modulus, which is 1 over square root of 2. Then we have that cosine theta will be equal to 1 over square root of 2, and sine theta will be equal to 1 over square root of 2. Cosine of the angle that can give us 1 over 2 is, and the sine of that angle can give also 1 over square root of 2, is the angle called pi over 4. This is the argument. This angle, pi over 4, is what we call argument. Argument of Z, which is equal to 1 plus I. We have found that argument is pi over 4. Then we know that argument is pi over 4. Modulus is equal to square root of 2. Before taking the polar form of complex number, let's take trigonometric form. Trigonometric form first. It will be equal to z equal to r cosine theta plus I sine theta. Then z will be equal to r is square root of 2 cosine argument pi over 4 plus I sine pi over 4. This will be equal to z, which is square root of 2 cosine pi over 4 plus square root of 2 I sine pi over 4. This is trigonometric form of a complex number. The polar form is z, which is equal to r e power I theta. It means z will be equal to argument times exponential constant power I times theta. R is the square root of 2 e, then argument is I pi over 4. This is z, which is equal to square root of 2 e pi over 4I is what we call polar form of this is polar form of our complex number. So I think you have seen how to calculate the polar form of complex number and how to calculate the trigonometric form of a complex number. Soon I'm going to come back with more exercises and we are going to solve it together. We are going to look together an example that concludes all of the topic we have learned together. Example, z is equal to square root of 3 plus I. You are asked to calculate the polar form of this algebraic form of a complex number. First, this is a real part, this is an imaginary part. Real part is 1, is the square root of 3. Imaginary part is 1. Then, first we can calculate modulus. Modulus is equal to square root of 3 square plus 1 square in square root. We shall get square root of 4, which is equal to 2. Then, cosine theta is equal to square root of 3 over 2. Sine theta will be equal to 1 over 2. Because cosine theta, we take real part over modulus. And sine theta, we take imaginary parts over modulus. Then the angle, when you find the cosine of that angle, you get square root of 3 over 2. And when you get the sine of that angle, you get 1 over 2. That angle is called, is the angle of 30 degrees, or pi over 6. The trigonometric form is z, which is equal to r cos theta plus I sin theta. It means that z will be equal to, the modulus is 2, cosine theta will be equal to pi over 6 plus I sin pi over 6. The trigonometric form will be 2 cos pi over 6 plus 2I sin pi over 2, over 6, sorry, over 6. This 2 has come here, and this 2 has come also to multiply here. This is a trigonometric form of our complex number. Then we are going to find out the polar form. Polar form is Z, which is equal to R E I theta. Then Z will be equal to the R modulus will be equal to 2 E I theta is pi over 6. Then the polar form of our complex number is Z, which is equal to 2 E I pi over 6. This is the polar form of our complex number.
Great.
We have studied the real part of a complex number and the imaginary part of a complex number. We have seen the operations of a complex number, addition, multiplication, and subtraction of a complex number. We have studied how to find the trigonometric form of a complex number and the polar form of a complex number. Thank you.